In this video, we'll discuss rigid motions, what they are, and some examples of them. So let's first talk about what is a rigid motion. So a rigid motion applies to geometric shapes and this could be triangles, it could be squares, rectangles, circles, basically any kind of polygon or even just lines in general. Anything that I can think of in a geometric sense, I can apply this to. And a rigid motion is I'm going to alter the position of a shape, so I may just move it left or right, but I'm maintaining all of its qualities. And by qualities, I mean like it still has the same side lengths, it still has the same angle size. The idea is I have not changed the shape itself, I've just changed where it's at. So like for instance, if I have an equilateral triangle and I reflect it, well, the reflection still is an equilateral triangle that's the exact same size. This would be one example of a rigid motion, and we'll talk about those and we'll have some kind of visual aids to kind of illustrate it. So let's talk about some particular examples of rigid motions. The first one of which is called a transition, or translation, I'm sorry. Sometimes also referred to as a slide. And this one, in theory, is very, very simple. And the idea is basically I'm just going to take an object. Let's say I start with this one on the right, and I'm literally just going to scoot it X amount of units to the left. It looks like about 7 units to the left. And a way of just kind of denoting things, so this is worth mentioning here. If we look at particular points, this B to what's this little B with a tick, that's what we call a prime in math. The idea is that these 2 points are linked. They're what we call corresponding points. They're like parts. Likewise, once I move A, it turns into A prime. That way I can kind of talk about each one individually, and then the same with C and C prime. And you'll find that that's pretty standard across the board when we're talking about rigid motions. When I move one thing to another, or from one space to another, in some way I have to somehow differentiate between the initial one and the after, sometimes called the image. So there's translation, pretty simple. You can move any direction you want. It doesn't just have to be horizontal. It could be vertical or some kind of strange line in between. But the idea is I'm just literally taking a shape and scooting it somewhere. And it's also worth mentioning, I know we talked about this before, but all of these side lengths from A to B is the same as A prime to B prime. Those are the same side lengths. The angles of this triangle are also preserved. The overall shape of this thing is preserved. And what I mean by shape is that the side lengths and the angles are still the same. So let's talk about another type of rigid motion. Another one that's pretty common is a rotation. And the idea with a rotation is that I'm spinning my object a certain amount of degrees, and it usually is about a certain point, so this would be the center of rotation. And what we've got here is I've got one example where I'm moving from the first image to the second image. That's a 45-degree rotation. And then the second one goes 90 degrees. Or I suppose you could think of it as it's 45 degrees off of the second image that's created. So this is another way, and again, you can see how the shape of the triangle is preserved, the angles are the same, the sides are unchanged. We're just really just kind of rotating this thing around, spinning it, if you will. Now it is totally possible that the point of rotation could land on a vertex and then it'd just be like a pinwheel. It's just going to spin as it does. And all of these examples I'm going to show you involve triangles, but you can apply them to any geometric shape. A quick note on notation here. Notice, again, we have the B to B prime, and then we have a second tick. This would be B double prime. It's just kind of denoting which one came first, which one came second, so on and so forth. And that pattern will continue for as many times as you rotate or slide or reflect an object. You can do this several times. So let's talk about the last one here. Reflection being the last one of the three. It's sometimes also called mirroring. And as the name would suggest, the idea is I'm going to reflect something about a line or a point. Usually we're talking a line, and in this case I have a line of symmetry here, where if you can kind of picture the object here on the right, if I was to mirror it over the axis, if I was to fold it over, then it would line up perfectly with the one on the left. And again, you can see how this is a rigid motion because the angles are preserved, the side lengths are all still the same. This means that this triangle that I have on the right, it's the same triangle as on the left, it's just it looks a little bit different in terms of how it's oriented, how it's positioned. You could also kind of make a link here. There's a way that you can technically create a reflection with a rotation and vice versa. But these are the three types of rigid motions. They're pretty straightforward, but this will lead into some very powerful results in geometry and mathematics in general.